Hello everyone, my name is Greg and today I prepared for you 5 questions from the latest meteorology exam, seen in the last 30 days across all authorities. Topic for today is pressure systems. Question number 1. Considering the North Atlantic region between 30 degrees north and 65 degrees north, together with the adjacent land areas during winter, the normal disposition of the main anticyclones at the surface is Azores and Siberia, Northeast Canada and Iceland, Greenland and the Iberian Peninsula, Siberia, Iceland, and Canaries. Okay, let's consider a global distribution of pressure systems. We know that it is dependent on patterns of global circulation, starting with equatorial low pressure belt, where strong convecting currents rise to the tropopause and then diverge north and south. At some point, this air cools down and starts to sink. When it hits the ground, due to friction, the diverging air movement is slowed down and cannot escape fast enough. It means that more air is added at the altitude that can leave the system on the ground, increasing the surface pressure. The circulation pattern that I have just described is called the Hadley cell. This circulation creates a belt of high pressure systems, anticyclones, around 20-40 degrees north and south. On the North Atlantic, such anticyclone is centered close to Azores and refer to it as Azores High. On the other hand, the strongest high on the northern hemisphere is the Siberian high, with the highest pressure of 1083.8 hectopascals, recorded in 1968. So, coming back to the answer, Azores and Siberia are the correct ones. So, answer number 1. And we are moving to question number 2. What can be expected in a hurricane? Wind speeds above 64 knots, limited visibility due to fog, vertical wind shear in the core, heavy precipitation in the core. Alright, so hurricane is a fully developed tropical revolving storm. According to World Meteorological Organization, there are 5 stages of TRS. Stage 1, tropical disturbance. Stage 2, tropical depression. Stage 3 and 4 are tropical storm and severe tropical storm, respectively. And finally, stage 5, tropical cyclone, hurricane, or typhoon, depending on region of development. One of the criterion for fully developed TRS is a sustained wind speed that exceeds 63 knots. So definitely answer number 1, wind speeds above 64 knots, will be the correct one. Now, let's go briefly through the rest of the answers. First, number 3 and 4. So vertical wind shear in the core and heavy precipitation in the core. In the eye, so in the core, we can find the calmest conditions throughout TRS. Calm or mild winds, and sometimes even a clear sky. Moreover, one of the preconditions for TRS creation is low magnitude of vertical wind shear between ocean and upper atmosphere. Strong wind shears can weaken or even destroy the TRS, interfering with the convecting motion in the ice. So we can see that these 2 answers are incorrect. Now, regarding limited visibility due to fog, convective activity in the eye and strong winds outside of it don't allow fog to be created. Although visibility might be reduced in the spiral rain bands, but due to heavy precipitation, not fog. So answer number 1 is correct. Question number 3. Except for the cold highs at the poles, the Earth's pressure zones shift position in accordance with the seasonal position of the sun. In the northern hemisphere, in the summer, the pressure zones migrate towards the South Pole, are stationary, migrate towards the equator, or migrate towards the North Pole. Here we have to come back to the global circulation, to the global circulation patterns. Remember that the pressure systems have their origins in the heat equator, where masses of hot air are generated. They rise, creating the equatorial low pressure belt, which subsequently generate the ITCZ, the intertropical convergence zone. The rising air diverge at the tropopoles, cools down, and sinks at the higher latitudes, creating the belt of high pressure systems. This pattern is known as the Hadley cells. Next patterns between subtropical highs and polar fronts are called the Ferrel cells. The air diverging at the surface from the heights converges at higher latitudes with polar air masses and rises, inducing the polar front depressions. The last area that complete the global circulation are the polar cells that forms polar anticyclones over the poles. Now, during the northern hemisphere summer, the heat equator and pressure patterns move together with relative tilt of the Earth towards the North Pole. Actually, to be more exact, it moves north from March to late July, and then from August starts a grid back to the south. So, for this question, answer number 4 will be correct. And answer number 4 is correct. Let's move to question number 4. The typical diameter of a tropical revolving storm is 50 to 100 kilometers, 200 to 500 kilometers, 100 to 200 kilometers, or 600 to 1000 kilometers. And the eye is typically 5 to 10 kilometers, 20 to 50 kilometers, 10 to 15 kilometers, or 60 to 100 kilometers. All right, so this is a quite simple and straightforward question. We just need to remember certain numbers. Here, the correct numbers are 200 kilometers to 500 kilometers for the diameter of the TRS and 20 to 50 kilometers for the eye. Be careful though to check the units, because in some books, these dimensions are given in nautical miles, as 200 nautical miles for stage 1 tropical disturbance diameter and 300 nautical miles for stage 5 hurricane, cyclone, or typhoon as an average. So just make sure that you check the units twice. So here, correct answer is answer number 2. TRS diameter is 200 to 500 kilometers, and the eye is typically 20 to 50 kilometers. And answer number 2 is correct. The last 5th question. In an intense trough of low pressure over Iceland during wintertime, the weather likely to be experienced is light wind, good visibility, and a high cloud ceiling, strong wind with subsidence at low levels, strong wind associated with an almost clear sky, strong wind shear, convection, and snow showers. Okay, so trough is an area of low pressure, and we can distinguish 2 types of them. The isobaric trough, where on surface pressure chart, the area of low pressure extends into the higher pressure region, and the trough line, depicted as a solid black line. It appears where mass of air, from some reason, become unstable. In both cases, the weather connected with these troughs is the one associated with low pressure system. We should expect a lot of convective activity with cumulonimbus clouds, heavy showers of rain, together with strong winds, strong wind gusts. Checking the available answers, we can see that the options given in answer 4, strong wind shear, convective activity, snow showers, since we are in winter over Iceland, perfectly describe a weather that we might encounter in a trough. So answer number 4 is a correct answer. And this answer is correct. All right. Thank you very much. That was all for today, and hopefully see you next time.